Recording in progress. Recording in progress.
Hello, how was your Thanksgiving holiday?
Busy.
Busy? Yeah, usually.
Lots of cooking, cleaning,
Mm-hmm. Hi, any questions from chapter 13? We are going to the last chapter now.
Still in chapter 12, you read, I'm still like taking a week and a half, almost half a week behind.
Oh.
And it just takes me that long to get it. And I still struggle with recognizing what question is asking me what thing.
Okay.
So I still work on that.
Take a notes, that's the only way.
I do. I'm taking notes. I'm on kind of
Each chapter, take a note for the important things, something different from the other.
Yeah. If I'm working through problem itself, I'm okay. Like another step, another step, another step. But then when I read the question, I'm like,
oh, the new one.
no, I have to recognize what it's asking. I'm working on it, but I have not gotten to chapter 15 yet. I apologize.
Where? Chapter 12?
So,
yeah. Are you still in chapter 12?
Yep.
That's okay. You still have time to do it. Our final exam is November, I think it's December 12th, right? Next week, Friday. So you still have this week to the next week, morning 7 day, 7, 8, and 9. Every day, plan to do something. Okay?
Yeah.
Yeah.
I mean, I am.
Every day, at least to do some problems. How about Michelle? Any questions?
Not at the moment.
Mm-hmm. Okay. Are you in chapter 12 or chapter 13?
Well, still working on both.
Both, yeah. Okay. How
and
about
I have the final practice test printed out. So
yes, you should print out and start practicing. Yeah.
I just got that today. I saw that it was there, so I downloaded it.
It's there.
It's gonna be a lifesaver.
Yes, we need to start sooner, earlier.
Oh,
so
yeah.
You can discover what kind of hope I still don't know and prepare for that. Okay.
Yeah, I've been looking for it, but it was long, so I couldn't open it. I got it today.
That's okay. Just a week to go. We almost done. Then you can celebrate the end of semester and Christmas time.
I'm not even thinking about Christmas. I'm thinking about the final.
Final.
Get that, and then all the rest of everything.
Yeah, relax. That's right. Just try harder this week to next week.
Yeah.
Get done. Okay. So last week we reviewed the chapter 12 as well, and so I posted the video for chapter 12, that one last week. So this week I plan to do chapter 13. So can give you, if you didn't start, it's okay, some heads up, right?
I'll start.
Something is coming up, and some summary for you to know, focus on what. Because if you read it yourself, it's a lot of material to cover.
No.
But when you come to the Zoom meeting, at least I summarize something is more important, so you can focus on that. Okay.
Yeah, it's helpful. The other day we did the summary too, and that's great. I went back and did that video. I didn't see the last video, but I reviewed the other one because when I hear it, I find it a little easier than
So chapter 13 is something very different from chapter 12, chapter 11, chapter 10. No, we didn't do chapter 9, chapter 8, earlier, anything earlier. So I'd like to go over something new, okay? And this is the last chapter we needed to cover. And this is an important chapter actually, because some university that you are going to be planning to transfer, sometimes the department chair or their counselor always email me to ask me, did you cover ANOVA test? And that's the chapter 13, okay? Because when you transfer, they have to evaluate through your transcript, and they saw you, oh, you took a statistic, and they want to make sure your course covered chapter 13. You covered 13, usually they take your credit all, okay? If not, they may ask you to take again statistics at the university again. Yeah. So because this one is the one usually we will apply in the real world, testing the things, because up to chapter 12, yeah, chapter 12 we are testing linear correlation to set of the data value to see if we increase one, we increase another one or not, okay, going up or going the different direction. One going up and the other one going down, okay, inverse direction, kind of like our algebra in high school. We mentioned the straight line going up with the slope positive or slope negative, those kind of things. But chapter 13 is try to compare the more than two things, 3 or more, okay? Because in the real world, very often we need to compare more than 3 or more, not just 2 only. Not just compare one set with another set. We compare maybe 3 or 4 or 5. For example, like we purchasing a car, we will do some research first, because right now so many different brands of the car there are available, even the electrical car, right? There's Tesla, there's all other brands, they already come out the electrical car. Even the BMW, Mercedes-Benz, and Honda or Toyota or Ford, or Chevron, everyone got some electrical car now. So you will see which one is better, right? So we like to compare 2, 3, or 4 among them to see which one is the best. That's why we often need to use ANOVA, okay? Because not only compare the two things. So this chapter is focused on comparison of the 3 or more, okay, 3 things or more, and we try to compare the average of the 3 things. Let's think of our older car like Toyota, Honda, Ford, and not the electric. Let's say gasoline car, and we know we will try to compare which one consume more gas, right, in 1 week. How much money paid for to buy the gas to fill up your car. And you also like to see efficiency, right? How many miles can run on the freeway, right? So when we compare the 3 or more, this will be useful, okay? And in a real world application, most of the time we need to compare 3 or more. So let me show you my ANOVA here. I put it on the whiteboard, so I'm going to share with you. I put it there already, here to share. Okay, I moved the question 1. Did you see that? the whiteboard shows module 13 homework, F distribution, and one-way ANOVA. Did you see that?
Yeah.
Yeah? Okay, good. This is the new data distribution. Okay, we have done normal distribution, like a bell-shaped, okay, normal. And we have done t-distribution in case the population standard deviation is unknown. We have and this data is collected from the parents' distribution, which is normal. Then we still can use a t-distribution to find out the t-test, the t-interval. T-test is statistical using a modified distribution. Then we have this, we also have done the binomial probability distribution, right? That one is kind of building up the histogram, okay? But this one we call F distribution. It's something we had to compare 3 or more. So we compare the mean, average of the mean, okay? And we also compare the variation of the mean of each group here, okay? The variation. What's the difference between 3 groups or 4 groups here of the different category of things, like Toyota, Honda, Ford, Chevron, or BMW, we put all together there, right? So we want to compare more than 3 or more. Then we need to find out the variation among these 5 or 4 different groups here compared to all the variation within the each group itself. That's why this is a different type of the data distribution constructed by statistician long time ago already. And for us now, we just take it to study. Okay, this is some type of the data comparison. We need to do that. Okay, so we just call F statistical from the F distribution here, and which is a ratio. We try to compare one to the other, and keep in mind we kind of set up a numerator, okay, a fraction numerator compared to a denominator. And numerator is one is about the variation we try to compare among the 3 or more to see each category, what's the difference here, and compare within each group. Each group we also collect data, maybe 10 data or 7 data, because even the same type of the Toyota car, we want to find out the car 1, car 2, car 3, any variation here. All this, let's say pick up the 10 car from the Toyota car. We want to see, are they really all the same? Will give us the same efficiency running, let's say running 40 miles per gallon or something like this. Because it's not every car will come out the same number, but we compare the variation. So some car may do better, 48 miles per hour. Some car may do worse, only 32 miles per hour, like that. So we will find out that those variation and we compare in average. So that's why this type of the distribution we call F distribution, and we need to put that something on the top and compare something at the bottom, okay? And we need a degree of freedom. So your homework exercise, question 1 is type of the question like this. This is the first question we ask you. When you do analysis of the variance, compare the means of the variable we have with the several groups, 3 or more, okay? And first question we ask you, like this example here from my version, okay? And you can look at your version. You open the module 13 homework assignment, should be similar, but just the numerical number data different only, okay? So you can also try to open up and use your own version, try out, and take my version as an example, okay? So this problem is asking you, when you are conducting this type of the test we call ANOVA, It's coming from analysis of the variance, okay, comparison, the means of the response variable we have. And this only applies to 3 or more groups here. So they say we have one they give the definition here first. The ratio of these two, you should have 1 from the numerator, degree of the freedom, and compared to the bottom will be the one we call denominator, degree of the freedom here. So we need to understand the degree of freedom first, because traditional way, when we're reading the critical value, we look at the table, ANOVA table, actually we call F distribution table. And they will ask you, what's the degree of freedom of all the comparison you have here, the numerator and the denominator, because they come out a different number of the critical value for us. So the first one we need to recognize, if they ask you the degree of the freedom from the top, the numerator, okay, which is also is the degree of the freedom of the treatment, okay. And the treatment is defined that here. Look at the statement. You can look at your version too. And my version here shows, maybe move more. Sometimes couldn't move. The number of the group -1. That's the numerator you have to do. So how can you apply? For our class, we just needed to know how to apply. That's more important. So to apply, we have to see how many groups we have here. And the problem said, yes, you intend to conduct an ANOVA with 5 groups here. So just like you can imagine, like 5 cars here, 5 different brands of the cars there. And you are going to compare them. So first question we ask you, what will be, what are the degree of the freedom of the numerator? That means you have to compare between, among the group first, okay? And the degree of freedom is defined as group number subtract 1. So if you compare 5 cars, 5 groups here, you just take a 5 minus 1, okay? We just take 1 less. Like we did in chapter 2, when we try to find a simple standard deviation for sample, we always take the sample size subtract 1, degree of the freedom. So for ANOVA, since we have numerator compared to the denominator, the numerator is defined, you have to take the group number minus 1, okay? So the answer will be just 4, okay? And the second question usually will ask you, what's the degree of freedom from the bottom part? The bottom part is looking for the error within each group there. This is a little bit different. This is defined as the number of the observation subtract the number of the group. Because usually in the past, a student always confused with this second one here. How can I find the second one? Should I just take there's another number here. I think it's 15, but I don't see that. Maybe it's too big, they don't see it. So then make it smaller. If you look at your own version, maybe you can tell me what you have there. The same number of the subject, and that the number of the subject is supposed to be n equal 15. My version is n equal 15. Okay, that means that each group here, for example, I check the Toyota car, Honda, and another one, Ford, 3 there. Okay, and each category we have here, I will select, let's say, select 10 cars. So 10 cars from the Toyota, 10 cars from the Honda, 10 cars from the Ford, and each car, their efficiency, right? If we check the mileage, will be different, okay? So how we do, if we select 15, n is 15 for each group here, then it's defined how we check the degree of freedom here. We need to take a group number, okay? Look at the definition here. The number of the observations subtract number of the groups. So number of the observation means if each group we have 15 data to observe here, you need to multiply by 5 groups first. So the total is 75. Usually students just answer 75 minus 1 and 74, and that's wrong. Okay. The definition is 15 times the 5 group. Each type of the car, let's assume the car, each type we have 15 different cars there. So the total data is 15 times the 5. Okay. Then you have to subtract number of the group minus 5. Okay. So that's why the answer will be 70. So that's the definition defined like this way. So it's just, I know the second one is kind of confusion here, but because second one we are checking the errors among all the data we have within each group, okay? And each group, if we have n equal 15, that means 15 data there. So 15 data times each group, they are the same number, so you times the 5. Total actually is 75 data, but we need to take one out for each group. That's why I subtract the 5. Okay, so ending the denominator will be 70. That's the degree of freedom for the denominator. This is the common mistake. That's why I bring up here to show you how to get it. Okay, and you can try out with your own version. When you open your homework assignment, question 1, you should have similar question like mine. It's just the number different. Instead of 5 groups, maybe you only have 4. And instead the sample size is 15 for each group here, maybe you only got 10 or 9. Okay, so you follow the same way, you will be able to get this answer right. Okay, but this we just follow the definition. But that also makes sense, because the first one is just comparison with all the group of the different brands we have here. That's why we just take 5 group, take one not less, 4 as degree of freedom. But the bottom part is try to calculate the variation within each group we have. If each group we have 15 data there, total how many variation could happen here? It's 15 times 5, 75. Then each group here, we need to take one less. So that's why I subtract 5. Okay, that's why answer is 70. So you can try out with your own data there, and to see you get right or wrong. Okay. Did you see the similar question? Your question 1.
You said did you similar question?
Yeah, question 1 from your chapter 13 homework. Did you get it right?
Yeah.
Yeah? Good.
Yeah.
So that's how you learn this definition here. Okay, and that's just definition. Okay, and by the time you will understand why we're doing that. But it's just statistics just follow this way. The total number, take one less for degree of freedom. But for this type of equation, it's kind of different, because we have 5 groups, and each group got a 15 there. Okay, 15 different number of the value will come out. So depends on what you have. You just follow this definition to get the answer out correctly. Okay, so now there's another type of question, like question 3 here. Question 3. Okay. Still cannot see how. Oh, maybe I should have made this one. Go back to the second line. Okay, it's a long statement here. And this question 3, providing some data. Usually in chapter 13, actually you will do better job on your chapter 13. Your chapter 13, we just based on what's defined, definition, and reading the given data. Because the problem usually hardly will ask you to really show your computer printout during the exam. And they just testing you, can you read the computer printout? Okay, because they assume in the future when you do the ANOVA test, you will use the technology to do it. Because if you do by hand, that's it all the work. Okay, when I was in the graduate school for the statistical doctoral degree, we had to do by hand, and that's just it. All the computation calculation are very complicated. But now, how many years passed already? And all the technology came out, computer software, graphing calculator. It's making the life easier because the computer programmer put another complicated formula into become the software, and we just apply. Okay, so where is my computer printout? So you can read this question 3. It's about some China health nutrition survey, health problem, and it came out. Okay, now I found it. It's here. Bring up. This is from my question 3. This is the computer printout. Okay, usually when you go to transfer to the 4-year university, I believe they will take you to the computer lab and ask you to use SPSS computer software or use another type computer software whenever it's available in the lab. But usually SPSS is the common one used. And when you enter the data, we come out in this one already. Okay, usually what we need to do, just enter the data. Okay, like now you are using the TI-84 83 calculator. It's like a mini computer. We enter the data under the stat edit, right? In the future, you just put it into the computer software. If we call the ANOVA out, you put the data in, and click on ANOVA test, and we come out of this. Okay. Today I will show you how you use your TI-8384 to get this too. Happen to this problem does not provide any raw data here. This one just testing your knowledge. Can you read the computer printout? Because when you go to the work, go to the 4-year university, they will expect you just use the computer software to come out the ANOVA test. They will not expect you to do the computation like a graduate student there. Okay, but probably now it's changed because at the time I was in the graduate school, my professor, I have to tell you, didn't know any technology at all. So how could they teach us how to use any technology? Actually, that time didn't have not much developed of the computer software yet. So we had to do everything by hand. That's why. I think that's part of the reason. But now we have technology. No one will ask you to do by hand anymore. So important, you need to know how to read this, how to input the data entry, okay? And when you have computer digital data given to you, the good thing is you can just copy and paste to the computer software program and click on ANOVA test, one-way ANOVA test or two-way ANOVA test. We come out the result for you like this, that's showing in front of us now. Okay, so this is some study about the 5 education plan they have in China, and I think they try to examine the effects of the health, nutrition, and family planning policies, programs, those and the government, the local government policies involved here. So there are originally 5. If you look at your question 3, there are 5 category of the things there. 5 educational plan. So the computer printout, and this is a study for their children under the age of 6. Okay, so the printout shows here. We need to know how to read this. First, you look at education. Okay, that's what we know. They have original education plan there, and DF is a degree of freedom, right? It's a 4. So that means the original program we have 5 there. Okay, 5 minus 1 become the 4. You saw here. And sum of the square, this is just adding up those different square, okay, to put the numerator compared to the denominator. And mean square, that's calculate the mean difference. So this detailed work you don't need to do anymore. When I was in school, I had to calculate all this one by hand. But now computer will do for us, okay. So what we need to know just this F value. F value is, I believe, is between these two, okay. So let me try to divide 4142.09 divided by this complete the formula. I think the formula even show on our book anymore, because today they expect us to use technology, so they don't even bother to show the student of what's the original formula. Original formula is really complicated, but you don't need to worry for this one here. Just F value, you have to read that. F value is the ratio between these two we are comparing, between the category of all the 5 education plan, and compared to whatever we have with the error, the variation within each category, those data. And they came out test statistic. This is our test statistic here. F equal 1.26. And more important is the last one here. PR is a p-value, okay? And p-value is 0.2846. So usually problem will ask you, what is the test statistic? Comparison of the error between the difference among the 5 groups compared to the difference within each group here. So that test statistics, this number 1.26, okay. And p-value is the probability we take our test statistics to the end or the extreme of the value to help us, can we reject null hypothesis or not. That's the p-value, okay, similar to what we have done before. So what you need to read is this F value and the p-value, okay. Then what do we need to know more? The questions. The question is right here. So let's practice. The question here, item A for this homework. I hope you can read it. Try to make it bigger. Large. Okay. So item A is asked us to write hypothesis for testing ANOVA test. And testing this, using this test is try to look for the difference between the average number of the hours spent on child care across the educational attainment levels here. So they have 1, 2, 3, 4, 5 original questions. There's data of the 5 category of the things, original data. So no hypothesis, we have to assume all these 5 educational plan, the mean is the same. The time we spend for average number spent on child care across the educational program here. We need to assume they are equal, okay? Just like we did before, for the linear regression test, we always, chapter 12, we have to assume no linear regression, the no equals 0, same thing like that. And like our hypothesis testing of the chapter 9, when we try to test the mean equals something or not, our no hypothesis always assume equal, right? Kind of similar idea. No hypothesis always assume all equal, okay? Then alternative is something very different than before, because we are comparing 3 or more, okay? So you just need to point out at least one of the means is different. Among the 5 categories there, if one is different than the other, then that means that all the 5 are different. We just need one is different. Okay, so That's why when you write the alternative, it's only needed to show at least the one of the means is different. This is very different from before we have been doing. Okay, so I want to call your attention how you write the alternative. Okay, alternative, put it like this here. Then how can we carry out the hypothesis test? What's the value of the test statistic? How to carry out this? We just need to click on the computer software or technology. This is the one-way ANOVA test. Just select ANOVA test. And why is one way? Because we only compare the mean only. If you have to compare something more, then it will be two-way ANOVA. But if you know how to do the one way, you can do the two ways. So, and for our class, we only require to do this one. So at least recognize you have such things to do in the future when you transfer to the university. And when the teacher say, "Oh, I saw you know how to do ANOVA test," then you, at least you have some knowledge already. Okay. So how can we carry out the hypothesis test? We just read from our computer printout. Okay. After we click on the one-way ANOVA test, we print out in 1 second, everything coming out right away. Now you have to know how to read it. You just say, okay, the value of the test statistic is this number, F value. Okay. If that number shows 1.26, that's the answer. Okay. And the p-value, just read from the last one there, written as PR from the computer printout, which is 0.2846. And how can we explain the conclusion here? Important that you have to answer our claim for the test of the 5 different educational plans. They try to test in the time spent on these 5 different programs here. The number of the hours spent are the same or different. Okay, so we just use the p-value here. Okay, you use the p-value, it's an easier way. Then you use the critical value. Critical value, you need to use traditional F table. That's very complicated to read that. So better use the p-value. So you just need to explain this one. You just say, okay, I know the p-value is 0.2846. So you just put the reason. Since p-value is 0.2846, which is not less than our significance level. Remember, we do hypothesis testing. Always it defines what kind of significance level we are testing here. If you based on the popular one we use is a 5%, 0.05, because when the problem didn't mention anything, we always assume this one, alpha equal 0.05. So you just need to compare to this number. So since the p-value is greater, it's not less than, because our p-value method for rejection is always the same thing. If the p-value less than the significance level, we reject the null hypothesis. Always remember this, don't forget. From your chapter 9, and actually from your chapter 9, 11, 12, 13, always follow the same rule. But this case, p-value is greater. You can see 0.28 is greater than 0.05. So since p-value is greater, okay, so we fail. We fail to reject the null hypothesis. When p-value is greater than the significance level, that means that our test statistic very close to our null hypothesis. It's not far away. When far away, p-value will be very small. But this p-value is greater than our significance level. The standard level is set up there. So still close to our null hypothesis, existing statement from HO here. So we fail. It's not sufficient evidence. Okay. So there is, we have to say there is not enough there's not enough or sufficient is not sufficient evidence to support that they are different. Okay, at least we cannot reject. That means we cannot support the other one. Okay, so there's not enough evidence to support that at least one educational program is different. Okay, so this one is a kind of simple one to remind you the process what we do. And what is important things I want to remind you is the alternative. You have to write at least one. Don't put the mu1 different, mu2 different, u3 different. If you have multiple choice question for you to choose during the exam, don't pick up that one. You need to pick up at least one of the mean is different. Okay, that's one I need to remind you. And this one, I bring another one here. This one is showing how to use your technology to input the given data. In the problem give you the data, right? And ask you to perform ANOVA test. How can we do it? Okay. So it's very small. I hope you can see it. Can you see it? Kind of small, but if you look at your exercise, you should see some questions similar to this one. Okay. Sometimes just so small. I don't know why. Let me see. Can I make it bigger? Can you see it? Okay. Huh?
It's kind of tiny, but it's like go closer to kind of see.
Very small, huh? Oh, I can cover the existing one and make it bigger. Okay. Can you see now? No, it's bigger. Okay. So important, we need the data, okay? And I want you to practice together with me. So once you do once, you know how to do it. Okay. So this exercise give you the original data there, okay? And they only provide 3 different group here. Better. I on purpose choose something shorter one. So this one we have 3 groups. Group of the study, I think. Okay. Group 1, Group 2, Group 3. 3 different type. Group 1 is internship. You go to some company to work, right? And to learn from the practice, from the actual experience. And Group 2 called co-op. And Group 3 is kind of work study. Okay, while you work, it allow you to be able to study. And I think they will pay the tuition. 3 different type. Okay, so however, we have 3 type to compare. Okay, so the problem I suggest you use technology to conduct a one-way factor ANOVA test. And we have data here. So when we have data given, how can I do it, right? You go to your calculator, okay, and hit the statistic, and edit, okay. When we need to input the data, always confirm, edit, okay. And we need 3. If you have 3 set of data, you need L1, L2, L3. If we have 5, you need L1, L2, L3, L4, L5, okay. So I go up to clear out my existing data. You just need to go up arrow key, go up and go up to L1, then hit the clear and go down. Everything is erased, existing data. So I go up, clear, go down. I use my calculator very often, so I have a lot of data here. I just clear out the 3 column here. The better you pick up L1, L2, L3, okay? Now you start to input your data. Under the L1, I'm going to put the group 1 internship. So I just hit that 17, 13.25, and 12.5, then 13.75 again, and 15.75, then 10.5. Okay. So under this internship, we have 1, 2, 3, 4, 5, 6 people join this one, right? And under the group 2, we also have 6 students join this type group 2. So I think this is their hourly wage. We are trying to compare the hourly wage here. So the group 2, under the L2, you just type in 14, enter, then 13.25, enter, 16, enter, 12.5, enter, and next one is 16.5, the last one 11.25. Then go to the L3 to input the data from group 3. I have 8.5, 11.25, 13.25, 12, 13.5 again, 9.75. So this problem try to compare the hourly wage, which group is paying more, or they're about the same. Okay. All right, I input all my data here. I hope you also input your data. Oh, I got the error. What's happened? Did it too fast. Okay, my L3 make a mistake here. 8.5, 11.25, 13.25, 12, 13.5. There's one more. 9.75. Okay. So make sure you input the 6 data for each group, right? Then after you input the data and correctly, right, the number correctly, then you go back to hit the statistic, then move to the right to the test, okay, and just scrolling down to the last one. I believe it's the last one. It's just like our last chapter. ANOVA. You will see ANOVA there. When you see ANOVA, press your key of the enter, and you will see your screen pop up ANOVA. Parenthesis. It's asking you where are the data. Okay, so you just put the second one. Okay, second one. That will pop up L1, your data under the L1. Then hit the comma. The comma is in the middle there, on the side of the X square key there. Hit that comma, then repeat again, second 2. Okay, that's for L2 data. Call in to your software program here. Then hit the comma, then second 3 for L3. So after you see your screen got L1, comma, L2, comma, L3, close parenthesis. Then hit enter. It's done. All those complicated formula, they already computed for us. You don't need to waste your time for that. And we confirm our F equal 2.763, and that is the test statistic. Okay, that's an ANOVA summary statistic. F ratio equal 2.763, because they only want, I think, 2 decimal, 3 decimal, 3 decimal only. And the p-value is right below. P-value usually we use a 4 decimal. So p equal 0.0951, right? 4 decimal, same as, just put on your blank of the homework exercise. Okay. Then conclusion, you have to use a p-value compared to 0.05, right? And you can see our p-value is 0.0951 compared to alpha 0.05. This p-value is greater than the alpha. So similarly to the other one we did, when it's greater, there is not sufficient data or evidence to conclude the starting wages are different. It's about the same. Okay, in average, it's about the same. So that's our conclusion here. So you just need to say there is not sufficient data to conclude the starting wage are different for the different groups. Actually, about the same. Okay. And you will see some question here on the top here asking you group means, because we compare the average of each one here. So group mean for the internship, how can I got this 13.79? Computer software or the ANOVA will help you to get this number. Okay. How do you get this one? You can do this way. Let me see. You can go back to, okay. Stat, calc, one variable stats, and list. You can, second one, change the list one, and go to calculate. Then you will see the mean. X bar equals 13.79. Okay, and you just round it to 2 decimal. And for the group 2, you do the same thing. Just go back to what we did in chapter 2, how you find the mean. Okay, so when we use a graphing calculator, we just do this way. And this is computer software, they will do everything for you. So anyway, we still can solve this. Just repeat again, stat, calc, and select number one variable states, because I'm looking for the group 2, okay, group 2, to confirm that the number 13.92. So I just confirm one variable states I want, enter. Then the list there, it just change to second 2, list 2, and go down to calculate, enter. We give it X bar equals 13.916666 at all the 6. Then you just round it to $13.92, right? 2 decimal. Same thing you do for stat, calc, and enter, and change the list to second 3, list 3, to calculate the third one. What's the mean of the work study average here? Because we have 6 different data there, right? Then repeat again. Okay, we come out the X bar equal 11.375. Oh, then round it to 2 decimal will be 1138, right? So that's how you complete your homework exercise. You can just use a TI 8384 to get it done. Okay, all these calculations. Any questions? So for the chapter 13 homework, usually everyone got 100% correct. Actually, it's a simple way, simple one. I think only 5 questions. Is that only 5? I forgot. Assignment on the statistical 1000.
You have a question.
Yeah, question 13.
I didn't understand what the null hypothesis was.
You don't have what?
I didn't understand the null hypothesis in here.
You don't have hypothesis?
What was the null hypothesis with this?
This is ANOVA. ANOVA, the name.
At the bottom here, it says there's not sufficient. So what do we need to prove? I didn't get that.
There is not sufficient data to conclude. Okay, let me share my original question here. You only have 5 questions only. Your homework, chapter 5, module 5. Okay, I will share my original question.
But just say,
because this one I cannot see everything. From my whiteboard, you cannot see it. I can stop share and go to my stat 1000 there. 1000. You can open yours too. open your module 13 homework. This is the one I copy and paste to the whiteboard. This is from your question 5 from your chapter 13. Module 13 homework. F distribution. One way ANOVA hypothesis testing. And we only have 5 questions only. So usually everybody got 100% correct on this one. Okay? Only the last question, you need to input the data to get the result like this. The other 4 questions is just concept. Reading the computer printout or follow the definition to get our degree of the freedom only. Okay. So this is hypothesis testing, same thing. And but a little bit different way, right? If I want to follow my 4 steps, my first step I will write as step 1, no hypothesis, that assuming the mu1 equal to mu2 equal to mu3. Okay.
That's what I'm asking.
That's your question, right? Yeah. If I write a complete, right, I'm supposed to show like this. I will write here on whiteboard. Because this is a homework exercise, they didn't ask us to do the step 1. So usually step 1, I will write a no hypothesis, HO, and I will say mu1 equal mu2 equal mu3, because we have 3 mean to compare. Okay? Yeah, that's how you're supposed to write out like this. Okay, here.
That's what I was.
Oh, that's what you're asking. Where is the hypothesis? The claim, right? Yeah. So we're supposed to write this. No equal mu1 equal mu2 equal mu3. Okay. Then alternative, okay, HA, I will write down at least one of the means. We have 3 means here to compare, 3 groups. Right? So we just say at least one of the means is different. That's it. That's enough. Okay. So this usually is, this is a step 1. Okay. And step 2 will be that the F ratio, F test statistics equal what's the number? Just reading from your calculator. And the p-value, use the p-value to compare with alpha. Yeah, step 3. And step 4, conclusion, right? Since this p-value is greater than the alpha, so we cannot reject the no hypothesis. If you cannot reject this equal, that means you cannot support the other one. Okay, yeah, right? I'm
saying that. Yeah, I forgot about that.
Okay, great. Yeah, very good. Any questions, Michelle or Kiara or Stephanie?
No, I don't have questions.
If you have your own question from your own version, you can ask me. Okay.
You pretty much answered it for me.
I
said you pretty much already answered.
For you. Okay, good. Yeah. And we will still meet the next week. So if you still have questions, you can ask. Or you can post on the discussions there. Okay. I have this question. How come I cannot get the answer right? And I will go there, take a look. I always check. Okay, so Michelle, you have no question? Okay. All right. So see you next week.
Thank you.
Bye.
Okay, bye-bye.